Hello, hello. On the back side of your note packet, here's my note packet. On the back side of my note packet, you should pause the video and write this down. So we're going to be reviewing radicals. Radical is a root. I'm going to be showing you two different ways that you can solve these problems, okay? Now, I'm going to focus on square roots. If there's no number in this location, it's always like a little twos there. This is a square root. We have cubic roots, we have fourth roots, we have fifth roots. We're focusing on square roots today for review of radicals. So again, I'm going to show you two ways to do these problems, and then you can choose how you want to solve them. Now, you can first do it by the factor tree. So I'm going to solve this one in two ways. So I'm going to add 48. I'm going to think, okay, what two numbers multiply to get 48 would be 4. 4 divided by 4 is 1. 8 divided by 4 is 2. I can split 4 up to 2 and 2. This could be 6 and 2. Here, this can be 3 and 2. So these are my factors. That means if I were to write this out, 2 times 2 times 3 times 2 times 2, all the numbers without trees, all the numbers without branches are the prime factorization. So I want to simplify this root. I'm looking, since this is a square root, I'm looking for pairs. So here's a pair of 2's. Here's a pair of 2's. This 3 had no pair. That 3 stays inside. So that means I can take out one pair of 2's because I'm looking for pairs. Here, I can take out a pair of 2's here. This 3 has to stay inside. So now this becomes 4 square root 3. And like many things in math, I can check my answer. I can go second x squared to get to the square root of 48 and see if that's the same thing as 4 times the square root of 3. And by golly, it is. That's good. The other way that you could solve these when you're simplifying my radicals is using perfect squares, but this is where you have to know your perfect square. You can rewrite 48. If I do 48, I'm going to divide by, let's say, 6. That's great. I could rewrite 48 as the square root of 6 and the square root of 8. However, that's not going to help me. What I want to look for first is see if 48 is divisible by perfect squares. So maybe I would try 25 first. Oh, that doesn't work. Now that was 5 times 5. Now I'm going to try 4 times 4 is 16. Does that work? Oh, that one works. And 3 is prime, so that's a good thing. So I can rewrite 48. That's the same thing as the square root of 16 times the square root of 3. Again, if you want to make sure that you are correctly writing this out, remember how we had that square root of 48 before? And it's still that same number. Now, I can take the square root of 16. The square root of 16 is 4. And then I still have this times the square root of 3. So these answers are the same. It's just a different way of getting to it. Here you have to be able to know your perfect squares. So right now, I want you to pause the video and try C or B and C, even though I didn't label it. So the second one, if you would have done the tree factorization, you have a pair of 2's and pair of 2's. That's where this 4 comes from. And then I have 1, 2 left over. Or 32 divided by 16, that's a perfect square, is 16 times 2. The square root of 16 is 4. Here for 720, I get 12 square root of 5. So if I were to do this with the perfect square, if I wasn't sure what, let's say 15 times 15 is, maybe I would try to do that one first. So 720 divided by 225. That doesn't work. 720, and I could also go like this. Divide by 14 squared. Doesn't work. 720 divide by 13 squared. So I don't have to technically know the perfect squares. 720 divide by, you should know that 12 squared is 144, so that one works. So you could also have done this with the square root of 144 times the square root of 5, which is still 12 square root 5. For these next three problems, it's the same thing, except a little bit different. So I'm going to do prime factorization. So this would be 4 times 8, 2 times 2, and 2 times 4. And when I said 4 times 8, I meant 4 times 7. What was I thinking? So really, I have a pair of 2's. Now this is already outside being multiplied, okay? So this becomes 3 times 2, because that one was out of the root. This 2 moves out of the root. I'm still left with the square root 7. So this final answer is 6 square root 7. Again, you can always check your work. So these problems, you will know if you simplified them correct or if you didn't. They check out. I want you to pause the video and try the next two by yourself. So here, if I do my factor tree, I have a pair of 2s, that one comes out. I'm left with this 3 on the inside and this 5. Those both have to stay inside. So this 2 gets multiplied by the negative 2 out in front, and the 3 times 5 get multiplied to be square root of 15. Now let's say if I do this by the factor tree and I found a factor though right away, that's a perfect square. I could now, wait a second, I'm just going to do this right away because I noticed that 36 is a perfect square. So now this 6 is on the outside, right here. Square root of 36 is 6, and I still have that square root 7. So either way that you did it, you should still have gotten 36 square root 7. And there you go. You have a great, a grand, and a wonderful day.